probability distribution models. There are few probability distribution models. Let's see them one by one. The very first one is binomial distribution. The binomial distribution is very useful in case of digital communication systems, wherein especially the transmission systems and even in statistical analysis. So binomial PDF, we know the PDF and CDF equations. The binomial PDF is given by summation k from 0 to n, it is n c k p raised to k 1 minus p n minus k into del of n minus k, and CDF is given by f of x. Fx of x is equal to the summation. Now summation runs from k is equal to 0 to x n c k p k 1 minus p raised to n minus k. The same del of x minus k will be absent here because it is CDF. CDF is a continuous function and PDF is a discrete function. So here del of x minus k will not be there. So it runs from 0 to x, and this one PDF runs from 0 to n. So the mean value of binomial distribution is given by mx is equal to n into p. So where n is the number of observations and p is the probability. And variance of binomial distribution is del x square, which is n into p, and 1 minus the probability. And standard deviation is given by del x, which is root of n into p and 1 minus the probability. So let's see a problem related to this. So suppose 5 digits are transmitted over a noisy channel. 5 digits are being transmitted with per digit error probability of 0.01. So the probability per digit is, the error probability per digit is 0.01 or 10 raised to minus 2. What is the probability that up to 2 digits will be in error? Also, calculate mean variance of error, use binomial probability distribution. So for this, the binomial probability is given by p of x of k. So p of x of k is equal to, it is n c k p raised to k 1 minus p raised to n minus k, where p is the probability of error per digit. 1 minus p would be probability of correct error. As this is error per digit, it is correct digit. So k is number of digits in error and n is total number of digits. So when we substitute n, k and the p values, so we get it is 0.01 raised to 2, and this is 1 minus p would be 0.99 raised to 5 minus 2, which is n minus k, because we are finding, calculate, so the probability that up to 2 digits will be in error means k is 2. So after calculating, we get it as 9.7 into 10 raised to minus 4. And the mean value is given by m into x, which is given by np as per this formula of, even we have learnt in discrete random variables. So it is n into p is equal to, n is 5 and p is the error probability. So the probability of error per digit is 0.01. So we are getting 0.05. So variance is by that formula np into 1 minus p. So which will be given by 0.049, and standard deviation is the same thing, np into root of 1 minus p. So let's write this. There are some properties of binomial PDF. So let there be n Bernoullian trials in which the probability of success is constant in any trial, that is P, and let Q is 1 minus P be the probability of failure, then probability of K success in n trials is given by P of x k, which is n k pk 1 minus p raised to n minus k, where k can take 0, 1, so on values. So means the binomial distribution can be used for Bernoulli's trials. Bernoulli's trials means the mutually independent events. For example, point. So if head happens, tail is not there, and if tail is there, tail happens, then the head is 0. So these kind of events, even it may be a tossing of a fair die. Then binomial distribution is applicable for, of course, mutually disjoint outcomes called the success or failure, winning or losing, these kind of events. The probability of success P is constant for every trial. Of course, if head comes, it is head and tail will have half, and the probability of success is half. If we are choosing head or tail, one of them will have same probability. Outcomes of different trials in binomial distribution are independent. In Bernoulli's trials, the outcomes are totally independent. And mean of binomial distribution is n into p, and variance is n into p into 1 minus p. So let's see a problem related to this. Among 120 applicants for a job, only 80 are actually qualified. If 5 of the applicants are randomly selected for an in-depth interview, find the probability that only 2 of the 5 will be qualified for a job by using 1. The formula of hypergeometric distribution, and second one, formula for binomial distribution with P as 80 to 120 approximately. Here n is 5 because if 5 of the applicants are randomly selected, and k is equal to 2. So k is equal to, because probability that only 2 of the 5 will be qualified, so k is 2. So, and n, because total number of applicants are n, and m are the qualified numbers. Then in such cases, by using the hypergeometric distribution, p of x is equal to k is found with this formula mk, and n minus m, n minus k, and n m. So substituting these values, p of x, now k value is 2 because 2 of them are to be selected, 2 of the 5 are to be selected. So m is 80, k is 2, and these values would be, so 120 minus 80, and this is 3, n minus k, 5 minus 2, it is 3, and here also n is 120 and small n is 5. So after solving this, we get this 82 is nothing but 80C2. So after solving this, 80C2, 80 factorial divided by 80 minus 2 factorial divided by 2 factorial. We know 80 factorial is 80 into 79 into 78, and this is also 78 factorial. It cancels and it is 2 into 1. Similarly, here after solving this, we get 0.1638. So binomial distribution, the probability of random variable x is equal to k using binomial distribution is given by, so because we are finding it by using the hypergeometric distribution, this way, by using the binomial distribution. So how it is to be calculated? The probability of random variable x is equal to k by using the binomial distribution is n k p raised to k 1 minus p raised to n minus k. And here p is nothing but m by n, which is 2 is to 3, 80 by 120. And putting these values, we get n is 5, k is 2, and this pk is 2 by 3 raised to k is 2, and 1 minus p is, so n minus k is 5 minus 2. So we get 0.1646. So by using both of these, so we get almost the same values. So this is regarding the binomial distribution. Then next kind of distribution is Poisson's distribution. The Poisson's distribution is a sort of binomial distribution itself, but the probability of success is very less in comparison with the number of trials n. So in such cases, we use Poisson's distribution rather than binomial distribution. So here in Poisson's distribution, we have n as almost very large, and probability of success is very less, very less, but n into p would be a finite value. So in such cases, when n was 5 in the above cases, now if n becomes like thousands and all, then it would be difficult. So in such cases, how do we find? The mean of the Poisson's distribution is same, it is n into p, and variance of Poisson's distribution is del x square is equal to n into p. There is no term like 1 minus p, because 1 minus p is almost equal to 1, because p is very less. So we write n into p. So let's see a problem on Poisson's distribution. For a noisy channel, 1000 digits are transmitted. Now, in case of the binomial distribution, we have considered a similar kind of a problem wherein 5 digits were transmitted, but here it went to 1000. So the number of digits are more here. Probability of error per digit is 5 into 10 raised to minus 5. There it was 0.01. 5 digits were transmitted and the probability of error per digit was 0.01, but this 5 into 10 raised to minus 5 is much lesser than 0.01. So what is the probability of getting only 2 digits in error? Same problem, but for different values of n and the probability of error. So also find the mean and variance. So now the value of n becomes 1000, probability is so, and k is same because we are finding it for 2 digits in error. And the formula goes this way. It is np, same formula, np raised to k raised to minus np divided by k factorial is the formula. So we write that. Now n into p we find first because it has to be substituted. So 1000 into 5 into 10 raised to minus 5 is 0.5. So n into p is 0.5 raised to k is 2 e raised to this n into p is 0.5. So after solving we get 0.076. So these, the value of the mean is nothing but n into p, which is 0.5, and variance is n into p. So this value is 0.5. Here the mean and variance values would be same. Then the properties of this Poisson's distribution are: when the number of trials are much larger, n are large, and probability of success p is very small, binomial probabilities are approximated by Poisson's distribution. Here we use lambda is equal to n into p remains constant when n is infinity and p is almost to 0. And probability of Poisson's distribution is given with this formula. Poisson's distribution is applicable when events do not occur as outcomes of a definite number of trials. Poisson's is applicable when events do not occur as outcomes of a definite number of trials. Here, a definite number of trials will not be there. The Poissons distribution is applicable to events whose probabilities of occurrences are extremely rare. Means the probability of error, the probabilities would be very less, but they have large number of independent opportunities for occurrence. And mean of Poisson's distribution is lambda, and its variance is also del x square is equal to, we can write lambda. So let's see a problem in connection with this. In the inspection of tin plate produced by a continuous electrolytic process, 0.2 imperfections spotted per minute on an average. Find the probabilities of spotting 1 imperfection in 3 minutes, at least 2 imperfections in 5 minutes, and at least 3 imperfections in 15 minutes. We'll see that. So let's solve these two and we can see that about 1 imperfection in 3 minutes. Means we are given with a process, electrolytic process, then 0.2 imperfections are spotted per minute. In 1 minute, 0.2 imperfection is there. Then, on an average basis, the probability of spotting, we need to find 1 imperfection in 3 minutes. So how much would be the probability of getting 1 imperfection in 3 minutes and 2 imperfections at least in 5 minutes, and so on. So in these kind of things, we need to make use of now number of trials, like how many bits we are transmitting, that is not just we are given with the imperfection. Here how many trials, how many plates were produced, no information is there. So in these cases the Poisson's distribution helps, and that says that Poisson's distribution is applicable for when events do not occur as outcomes of definite number of trials. So let's find this one imperfection in 3 minutes. Now in this, we need to get the values of this lambda and k just. So here 0.2 imperfections per minute is nothing but the value n, it is Rp value itself. 0.2 imperfection is P, and we are given that in 3 minutes. So 0.2 into 3 is equal to 0.6. So 0.6 will be the value of our lambda. So lambda is n into p. Our n is 3 and Rp is 0.2. So we get 0.6. And 1 imperfection in 3 minutes. So number of imperfections that we are supposed to find is k is equal to 1. So lambda and k are there, we can go for finding. So by Poisson's distribution, now as 1 imperfection is there, x of 1 will write lambda value is 0.6, e is as it is minus 0.6 divided by k is 1, so it is 0.329. At least 2 imperfections in 5 minutes. So n into p becomes n is 5, p is 0.2. We get 1 imperfections in 5 minutes. And what is the probability of having at least 2 imperfections in 5 minutes? Means k becomes 2. Number of imperfections. So to find that, when we need to find, so as per the equation here, x of k n p raised to k e raised to minus np divided by k factorial. From this, we need to go for substituting the different values k. So let's substitute. So probability of having at least 2 imperfections we need to find. So we find what is probability of 0 imperfections, means when k is equal to 0. When k is equal to 0, n into p would be 1 and it's 0.3678 we get. And when k is equal to same probability when one imperfection is there, then it would be 1, lambda is 1, so 1 raised to 1 and e raised to minus 1 divided by k factorial. So after solving this, again we get 0.3678. Then at least 2 imperfections are found, like having probability of having at least 2 imperfections is nothing but 1 minus probability of having 0 and 1 number of imperfections. So which will be 1 minus these two values, which will be 0.644. It is 0.2644. So some other kind of distributions we'll see in the next video.